Hi, in this tutorial we are going to solve a question related to synthesis of ethers. The question asks, how would you prepare the following ethers using either Williamson synthesis or acid-catalyzed reactions of alcohols? Let's look at two ethers here in the question. The first one is a symmetric ether. It is ethyl ether, so it is diethyl ether. Let's write the name of this ether. This is diethyl ether, and let's look at this ether. It's not a symmetric ether, it's an asymmetric ether, and this part is isopropyl, and this part is there is a benzene ring and a CH2 group, so this part is known as benzyl. So this is, let's write the name here, benzyl isopropyl ether. So then, after naming these two ethers, let's analyze what we can do for the synthesis of these two ethers. We know that symmetric ethers can be synthesized by acid-catalyzed reaction of alcohols, and asymmetric ethers can be synthesized using Williamson ether synthesis. So basically, the first one is a symmetric ether. We can use acid-catalyzed reaction of alcohols. Then the second, we have to use Williamson ether synthesis. For part A, for diethyl ether, the alcohol part is ethyl alcohol. So let's write here. So we have ethyl alcohol, and if we use an acid catalyst, let's say that H plus, and the alcohol will be protonated, and then we can use an SN2 reaction between a protonated alcohol and the neutral alcohol. So this is the first step. In the second step, the same alcohol is going to react with protonated alcohol. Now the leaving group in the SN2 reaction is water. It's a good leaving group. So what's going to happen? So basically alcohol will act as a nucleophile, and the protonated alcohol will act as a substrate, and we will have an SN2 reaction, and we will generate a protonated ether plus water as a leaving group. Then in a subsequent reaction, protonated ether will be deprotonated by water, and we are going to generate neutral ether, diethyl ether plus hydronium ion, which was the acid catalyzed. Basically, we regenerated the acid catalyzed. Let's look at the second part of the question. Second part of the question asks, how would you prepare benzyl isopropyl ether? So basically we have to use Williamson ether synthesis. In Williamson ether synthesis, that's again an SN2 reaction. We use either primary halides or tosylates as our substrate, and the alkoxide is going to be our nucleophile. So let's look at what we can do for the synthesis of benzyl isopropyl ether. Definitely this part is going to be our nucleophile because it's going to be a secondary alcohol, and if we deprotonate secondary alcohol, we are going to generate an isopropoxide nucleophile. Then if we use this part as our substrate, it's going to be a primary halide or tosylate. Let's use halide, and let's use the nucleophile of this part. So our nucleophile will be this molecule. So it's going to be isopropyl we have to use the deprotonated form of isopropyl alcohol, because it's going to be a very good nucleophile. Isopropyl alcohol is going to be a very weak nucleophile. So this nucleophile is going to react with, let's write here, benzyl chloride. Let's say we can use chloride. So what's going to happen? We are going to have this reaction. This oxygen, negatively charged oxygen, will act as our nucleophile, and chloride anion will be our leaving group. So we are going to generate this molecule, which is benzyl isopropyl ether. Okay, the question sometimes might be this: how are we going to prepare the alkoxide nucleophile? Basically, you can react isopropyl alcohol with a very strong base like sodium hydride, and sodium hydride is going to deprotonate alcohol, and it's going to generate hydrogen gas plus this nucleophile, which is isopropoxide. Then it's going to be a very good nucleophile. So in this question we solved or we propose two methods to synthesize ethers. The first one was a symmetric ether. Symmetric ethers can be synthesized via acid catalyzed reaction of alcohols. Alcohol will be protonated first by acid, then alcohol is going to act the nucleophile, and protonated alcohol will act as a substrate. Then we will have an SN2 reaction. And in the second part, we propose that we have to use Williamson ether synthesis, because it's an asymmetric ether, and in this synthesis we have to use primary halides or tosylates as our substrate. And because this is an SN2 reaction, SN2 reaction work best with the primary halides or tosylates, then the nucleophile could be a secondary alcohol, or any good nucleophile will react. Thank you so much for watching.